In this video, we will talk about how the tensile pixel model explains the laws of physics as described by the theory of relativity. To summarize, the model we have is explaining how the universe initially originated as a single pixel, and then there were new pixels created surrounding that pixel. And with that, over billions of years, we ended up with this very complex universe with uncountable number of pixels that surround us and create the space. The tensile pixel model does modify the theory of relativity significantly in order to develop a coherent model and have it be consistent with quantum mechanics as well. The most important change that is made is that, as you know, theory of relativity was developed in two different stages. The first stage was the so-called special theory of relativity. And in special theory of relativity, there were two main postulates that Einstein used to formulate it. One postulate was that the speed of light is independent of the emitter of that light or the detector of that light. So they can be moving at any speed and the speed of light remains unchanged. Now this comes from the Maxwell's theory of electromagnetism. However, it was used to formulate the theory and derive some very important laws of nature, such as E equals mc squared. Of course, the laws can all be derived mathematically once we explain the postulates of the theory of relativity. And so in the tensile pixel model, we describe the speed of light as the fastest speed possible, and it results from an axiom which states that a photon can travel from one pixel to the adjacent pixel in each iteration, and that is the fastest speed possible. Anytime when the speed is lower than the speed of light, such as when an electron is moving, it's staying in the same pixel in many iterations before moving, and when it's moving in all different directions in a random manner in different superimposed multiverses. So in that way, all particles with mass move slower than the rate at which a photon moves in each iteration. The reason for why other massive elementary particles can't catch up with the speed of a photon is explained in the figure. The figure shows that a particle with mass actually shrinks a pixel, and then it allows for creation of a new pixel because of the void created when the pixel got shrunk. And by doing so, the elementary particle is moving to the newly created pixel instead of going to the next pixel. And in doing so, it can never catch up with the movement of photon. And so that explains why particle with mass cannot catch up with the speed of a photon, and that puts an upper limit in how fast any particle in the universe can travel. The second part of this, the theory of the special theory of relativity, suggests that the movement of different particles is independent of the reference frame, because there is no ether in this world which would provide the universal reference frame. In general theory of relativity, Einstein proposed that the source of gravity is distortion in a four-dimensional space-time continuum. This theory has been very successful in explaining how the celestial bodies and galaxies move around in this universe and how the universe is expanding. However, it does not work well with quantum mechanics, and no one has been able to combine quantum mechanics and relativity into one unified theory. What Tensile Pixel Model proposes is that our universe actually is a three-dimensional space, and the fourth dimension is time, which is separate and is derived from the iteration number of this logical construct. And in doing so, we explain gravity in a different way. What is being proposed is that when a pixel shrinks, it creates new pixels, and then that allows for massive objects to actually have a pixel density gradient. And so we explain gravity by describing how the higher the mass of a celestial body, the greater the pixel density gradient that will surround that celestial body. And by doing so, we're able to explain how a massive object will move towards another massive object. And in that way, we provide a different explanation of gravity instead of this four-dimensional space-time distortion. So in that way, we're able to describe the world in a three-dimensional manner. In this manner, since quantum mechanics treats the universe as a three-dimensional space, and in Tensile Pixel Model, we're treating the space as a three-dimensional space and keeping time as a separate quantity, not part of a four-dimensional universe, we're able to unify quantum mechanics and relativity. Additionally, we're able to explain how gravity arises from a density gradient of pixels rather than through a four-dimensional distortion. In addition, we also explain many of the phenomena that were critical in providing evidence for the theory of relativity, in particular, curvature of light around massive objects such as the sun. And there again, if there is a pixel density gradient, as the photon moves from one pixel to the next, it will get curved just as it is described in the general theory of relativity. We also prefer this three-dimensional model because one of the central tenets of Lajibard's paradigm is the law of simplicity. What we describe is that consciousness algorithm can arise only when the universe is complex enough to support that algorithm, but not so complex that the algorithm isn't able to interpret and analyze it. And so a three-dimensional universe is the Goldilocks point in our universe, whereas simple algorithms such as a chess game is not complex enough to support consciousness algorithm, and a four-dimensional universe is too complex for a consciousness algorithm to arise. Even though the ultimate realm has every conceivable axiom set, including million-dimensional universes, none of those are expected to be physical in nature, just because the complexity does not allow for a consciousness algorithm to develop. We also are able to use the Tensile Pixel Model to solve many of the conundrums that are currently unanswered. For example, the value of the universal constant as described by Einstein gives very different values when we use the vacuum energy as described in quantum mechanics to have that value. What the Tensile Pixel Model is proposing is that you are not using energy to expand the universe. So the vacuum energy is not responsible for expansion of universe. What's responsible for expansion of universe is the creation of new pixels because of movement of massive particles within the universe. And in doing so, we have the opportunity to solve this puzzle of this mismatch between the energy or the universal constant as calculated through vacuum energy and through the cosmological observations. Um, there are many other conundrums too that can be solved. For example, in the black holes, one is left with the possibility of singularity at the center with infinite density of mass, and that is considered non-physical. In the tensile pixel model, one pixel can be occupied by only one elementary particle as the axiomatic requirement of the principal zone axiom set. And for that reason, the most dense object that can exist in the universe would be an object where every pixel is occupied by the most or the heaviest elementary particle. So even though you can achieve very high density in a black hole, you cannot achieve infinite density, and that way the puzzle of singularity is resolved. This is again a complex topic, and we go deeper into it in the book, which is Lodgevar's A New Paradigm for a Grand Unified Theory. Thank you very much. It was a